Welcome to the Psychology Podcast, where we give you insights into the mind, brain, behavior, and creativity. I'm Dr. Scott Barry Kaufman, and in each episode I have a conversation with a guest who will stimulate your mind and give you a greater understanding of yourself, others, and the world we live in. Hopefully we'll also provide a glimpse into human possibility. Thanks for listening and enjoy the podcast. Today we have Richard Heyer on the podcast. Dr. Heyer is Professor Emeritus in the School of Medicine, University of California, Irvine. His research investigates structural and functional neuroanatomy of intelligence using neuroimaging. He created an 18-lecture video course, The Intelligent Brain, and authored The Neuroscience of Intelligence. He is co-editor of the Cambridge Handbook of Intelligence and Cognitive Neuroscience. He is editor-in-chief of Intelligence, a scientific journal, and Dr. Heyer received the Lifetime Achievement Award from the International Society for Intelligence Research. Congratulations on that award, and looking forward to talking to you today.
Well, thanks very much. This has been a long time in coming. I've known you for years. I'm glad we are finally able to do this.
Yes, I have known you for years. I remember us talking at this Harvard Visual Spatial Conference. That must have been like a decade ago at this point.
At least, yeah. It was interesting because we had brain images of visual spatial tasks at the time. By 10 years ago, a lot of people were doing brain imaging. When I started, it was really an astounding new technology.
Yes. Well, let's go back because you started off looking at waveforms, right? You did an EEG.
I did.
Isn't that how you kind of start off? So can you tell us a little about your first initial findings, which actually, I believe, if I remember correctly, surprised you? You weren't expecting to see what you saw.
Well, let me go back and think about that EEG work. It was done at a time when EEG research was just beginning to do brain mapping with EEG. And by today's standards, it was pretty rudimentary. But it was kind of interesting to see waveforms move back and forth across the brain as thinking was going on or perception was going on. And I did some work building on the work of a lot of other EEG work, looking at correlates between these electrical waveforms in the brain and intelligence test scores. And we found some interesting things, nothing really amazing. The real surprising work was when we moved from EEG to positron emission tomography.
PET for short.
Yeah, PET. And so I was one of the first psychologists that had access to this technology, because I moved from Brown University out here to the University of California at Irvine because they had acquired one of the very first commercially available PET scanners in about 1986. It was in the psychiatry department of all places. This was extremely unusual. So I was recruited into the psychiatry department, and I came because I had this access to this really amazing technology. And the first study I was able to do with PET was looking at brain metabolic rate while people solved reasoning problems on an intelligence test. And the result of that was extremely surprising because we did see areas of the brain that, quote, lit up, that were more active while people were doing this test. But the surprising and unexpected thing was the more those areas lit up, the less well they did on the test. There were inverse correlations between glucose metabolic rate, that is brain activity, in these areas, and how well they did the test, leading us to conclude that it wasn't how hard your brain was working that made you smart, but how efficiently it worked to make you smart.
Oh, I'm just going to jump right into this. Sex differences. Why not? Why not? I was going to start off with a whole bunch of other things, but I feel like, why not? This kind of illustrates a point, though, that I think is really interesting. So from all the data I've read, there is no average sex difference in intelligence or an IQ in the general factor. There may be on specific factors where males on average might have an advantage on certain tests and females might have an advantage on average on other tests, but at the global level. However, obviously, it's a well-known fact that female brains are smaller on average than male brains on average. And so people have explained that in saying that female brains actually are more efficient. So do you see the link I just made there to what you were saying?
So absolutely. That was one of the first questions I would get. No one has actually proved that female brains are more efficient, but there's a lot of evidence that supports that hypothesis. Our PET data would be one. We also did a study where we correlated the amount of gray matter using magnetic resonance imaging, a different kind of technology than PET, that we could determine how much gray matter there was throughout the brain. And we correlated that with IQ scores. And we found there were certain areas where the more gray matter you had, the higher your IQ score. And that was interesting because the areas were basically in the front of the brain and in the parietal areas on the side and the back of the brain. But when we broke the sample out into men and women, it was the men who had the correlations in the parietal lobes, and it was the women who had the correlations predominantly in the frontal lobes. This suggested that men and women equally matched on IQ score, important to mention, may have different parts of the brain involved in the kind of problem solving that IQ tests measure. And so the simple way to think about that is profound in its simplicity. Not all brains work the same way. Now, this will come as no surprise to most people, but in a field dominated by cognitive psychologists who regarded individual differences as error variants in experiments designed to generate minimum individual differences, assuming they were looking at the general response of the brain that would be common to everybody. In fact, not all brains work the same way. Men and women may have brains that work somewhat differently to arrive at the same result. Now, that's because there's differences in the amount of white matter connections between men and women. These are average group differences, by the way. There's a lot of overlap.
Yeah, I keep being sure to say that. Yeah. I keep saying average.
Yeah, got to say that all the time.
All the time.
And so it's interesting to the brain imaging world that around the year 2000. God, it's like 2 decades ago already, as more psychologists got access to MRIs and started doing their own brain imaging experiments, they were surprised generally at how the brains of the individual subjects look so different on MRI. And by adding them together and taking a group average, they immediately recognized they were losing a lot of information. So I have always proposed to my cognitive psychology friends that they do the following experiment, that they take the most classic cognitive MRI study and replicate it separately in men and women, or separately in high IQ people and average IQ people. This is to just illustrate the potential power of an individual difference approach, because I believe individual differences is the key to understanding all kinds of neurobiology.
For sure. I agree with that. You're bringing back lots of memories. Maybe you don't know this, and I'm sure my listeners don't know this, but I did my master's thesis at Cambridge University with Nicholas Mackintosh, who was a well-regarded intelligence researcher. And my thesis with him was on how men on average and women on average solve visual spatial problems differently. And it was interesting because women on average tended to solve it using verbal labels, in a way, and men on average tended to visualize it more than the women on average. We found that interesting, and we're trying to explain differences in working memory based on different strategies. So you're taking me all the way back to kind of the start of my career, looking at, really interested in difference in strategy use and how that relates to intelligence and our visual spatial working memory, for instance. So anyway, thanks for bringing me back.
Well, I'm glad you mentioned that, because I never met Nicholas Mackintosh, and he wrote one of two classic textbooks in the field. I think his book was called IQ and Intelligence.
IQ and Human Intelligence.
IQ and Human Intelligence. And the other classic was Buzz Hunt's book, Human Intelligence. And I have just finished a few days ago sending off the final manuscript for the second edition of Buzz Hunt's book, Human Intelligence. We now call it The Science of Human Intelligence. And I wrote it with Roberto Colom. We were both friends of Buzz Hunt. And it's too bad. I really admired Nick Mackintosh's work. Up until yesterday, I had it right here on my desk, because I would refer to it from time to time in writing our book. And he passed away about, 2 or 3 years ago?
Just a couple of years ago.
Yeah, it was a shame.
Big tragedy. Big tragedy.
By the way, did you know he actually gave an invited interview at an ISIR meeting?
I saw the video of it.
I had arranged that, and then I couldn't go to the meeting. But that is online if people want to see his views on intelligence.
Thank you. Thanks for plugging that for on behalf of Nick, and I can put that in the show notes for sure. He really inspired me so much, his way of thinking so clearly about the topic, and I would also say compassionately. The way he covered things, he didn't shy away from any topic. If you look at his textbook, he's a whole chapter on race differences, for instance.
Yeah.
He doesn't shy away from it, but one doesn't leave reading his discussion about it thinking, oh, he's a racist, or thinking, oh, he's not being even-handed. No, you'd be hard pressed to walk away from reading Nicholas Mackintosh feeling that you've been shortchanged intellectually, if that makes sense. It
does. Buzz also had a chapter on that in his book, and it was one of the last chapters we wrote. And it's a tough needle to thread the eye of that,
to say the least.
When I did the 18 video lectures for the great courses, I put in a whole lecture on race and IQ. I would tell you the company was a little nervous about this, but I said, look, if we do it right, this will explain to people why this is important to know about. And I was able to do a lecture that observers found balanced and informative. The hope was people would walk away without racist support or whatever racists get from this kind of stuff, and just kind of learn about why this doesn't go away. It's a topic that is important for many reasons, but it's so uncomfortable. It's just so uncomfortable, and it's so difficult to have a conversation about it.
I'm excited to announce that the Psychology Podcast now has a Patreon page. You're going to love our new exclusive episodes just for Patreon subscribers. There'll be about a couple a month that only will be accessible if you subscribe through Patreon. Also, there will be all sorts of tiers that will give you the opportunity to not only access Patreon-only episodes, but you also get an opportunity to join the community, ask your own questions of new guests, and even have a 30-minute Skype call with me each month. Also, if we reach our monthly goal, we will donate 10% of all proceeds to an organization dedicated to helping people with their mental health. Check out our Patreon page today by going to patreon.com/psychpodcast. That's patreon.com/psychpodcast. Okay, now back to the show. Well, my view is that I think it's actually unfortunate that discussion of the exciting findings of the science of intelligence more generally consistently gets hijacked by that topic. So that's something that infuriates me, because I find individual differences in intelligence far more interesting and valuable to investigate than race differences, if you want to know my opinion.
I couldn't agree with you more. In fact, I never commented on the race difference thing up until I did this lecture in the end. I recorded at the end of 2013. So I literally went decades without any public discussion of this. I know or have met most of the players in that space. It's a relatively small space compared to the rest of intelligence. And so, just from a historical point of view, I had many, many private conversations with most of the key people. And in private conversation, there was no racism. There was just kind of an interest in explaining away these test differences, or it's not necessarily explaining them away, but explaining where they came from. Arthur Jensen was famous for this. He was a bit, had a touch of Asperger's syndrome.
Oh, that's interesting. Is that what you were diagnosed? Have you met him? Did you meet him?
I spent a lot of time with him at meetings.
Oh, you're the first one to ever say that to me. So yeah. That's interesting.
Well, I didn't fully appreciate this until after he passed away. But it turns out I understand that a relative of his had Asperger's syndrome. And suddenly it kind of fell into place.
It clicks, yeah.
Because he was absolutely unflappable in the face of enormous hostility and criticism. He just stuck to trying to explain to people what the data were. No matter how technical the data might be, he felt he could explain it in a neutral way. And he said publicly and privately he would be the first to change his mind about any interpretation of the data if new data came along, and that he hoped that any hypothesis that he had could be disproved by data. He wasn't afraid of that at all. He was really an advocate of the scientific method.
Yeah, I to be vulnerable a second, I have to admit, I think I'm a bit on that spectrum to a certain degree where sometimes I don't mean to get in trouble, and my curiosity leads first, and then I get in trouble. The curiosity killed the cat sort of thing, and I truly don't have malevolent intentions. I'm just being curious, and then if I've hurt anyone's feelings, of course I feel horrible about it because I also have compassion. But I can resonate with a group of people who are just absolutely just ravenously curious about all sorts of different topics and who really step in it sometimes as a result.
Well, of all those people that I have met or knew mostly at meetings, often their work when presented at intelligence meetings was heavily criticized. People from the audience would get up and say, it just doesn't make sense, or you're misinterpreting that. Only one of these people, I won't say who, in private conversation struck me as holding racist ideas. And that's one out of.
I know exactly who was in your head right now, just so you know.
Very probably you do, but
I know
there's no sense naming this person. So
no, I won't say
the point is that most of the people who engaged in that kind of research did it to understand education achievement differences.
Yeah,
and because they wanted to fix it. That's where the whole Head Start compensatory education movement came from. So it's got a venerable history of good intentions. It did get hijacked. Today, there's a tiny number of people who work in this area. I get papers submitted to the journal I edit on this. We probably, I can't say for sure, but we probably reject more than we accept. I don't have a policy of rejecting papers because they are in topics that we censor or anything like that. We kind of have a wide open gate when it comes to academic freedom in terms of getting papers into the process. But I make sure they get a fair peer review. And if they make the peer review, then we publish them. If they don't, we don't. Unfortunately, there are a small number of people on Twitter and other social media who seem to relish in debates about this.
Yeah,
I've noticed. Debate this on Twitter in any reasonable way. The issues are too complex. the technical aspects of the data are really require a lot of explanation about what the data mean and what they don't mean. And I have really avoided, Twitter fights about this. What I have noticed on Twitter, occasionally, somebody attacks me for doing intelligence research. It's very occasional, and it's easy to ignore. The hostility about intelligence really does. It's really a shame because, as you say, there's so much intelligence research that's interesting and provocative and positive. I've spent decades speaking to the public about intelligence. I can't even tell you how many public lectures I've given. There's a tremendous public appetite to know about intelligence and what the research says. And intelligence slowly and steadily has been moving more mainstream than it's been since the 1960s, partly because of brain imaging work, because the idea that intelligence test scores robustly correlate with things you can measure on brain imaging, that pretty much puts the argument to rest that intelligence test scores are meaningless and aren't real, they're just statistical artifacts.
Well, I think those are two different things. Something can be real and be meaningless.
Well, okay, so, fair enough.
Come on.
Fair
so, but when you look, what I want to get to all the really exciting, because there's a lot about intelligent research that obviously excites me. That is how I started my career, and I would live in the library in Carnegie Mellon as an undergrad. I'd live in the library reading every book I could possibly get my hands on about human intelligence. So me and you absolutely can nerd out. I feel like I want to just address that annoying elephant in the room that keeps hijacking the discussion really quickly so we can just move on from it.
Right.
So the race differences. Now, this is probably, this is a horrible time to even bring up that topic because there's such racial tensions in America. And I think there's value in being sensitive to the fact that we have a long way to go in America to reduce racism. And I don't want to contribute to racism one iota. But I also enjoy looking at data, and I enjoy looking at various sources of information to try to. I'm a firm believer if we want to make changes, we need to look at reality as clearly as possible, and it needs to be built on reality. Change needs to be built on reality. The question is, what is the reality? And I'm wondering if in like 2-3 minutes we can summarize that state. And I'll tell you my summary of it is that there still exists a significant difference on average, group differences between blacks and whites on average on IQ scores. But I have yet to see one study showing that the cause of that any of the group differences are explained to any degree, let alone a sizable degree, by differences in genetics. And not only that, but I think the really important point here, and you correct me if I'm wrong, because I really do want to get into the exciting aspects of intelligence, anything that we say today about the science of individual differences in intelligence, you cannot automatically extrapolate that to the group level. And that's a point that I just really think needs to be hammered in these discussions so that we can finally, once and for all, have a nuanced, truthful, and interesting discussion about individual differences in intelligence without it being hijacked. So do you resonate with anything I just said?
With all of it, there's virtually nothing I disagree with. I would talk about it a little differently, though. You are correct that there has been a persistent finding over decades that different groups have average test score differences. And the presumption early on was that all of those differences were due to lack of educational opportunities or other social cultural aspects. The hypothesis that it might be partially genetic started to evolve as compensatory education efforts were tried to close those education gaps, hoping to see a reduction in the test score gap, which never happened. And so as frustration mounted about the inability to minimize that gap through educational opportunity and other programs, people started to wonder, maybe genetics has something to do with it. That was an incendiary train of thought in the late 1960s when it really started to take hold, right through the 70s and 80s. As more was learned about genetics, however, the concept that genetics was a deterministic and limiting factor kind of got that understanding of genetics evolved into a more sophisticated understanding that genetics essentially was probabilistic, not deterministic. And this really is a very important concept, and it really changed the way people started to think about genetic propensities or genetic potential. So you might have the potential for heart disease, and you can minimize it or maximize the probability of you getting heart disease by doing lifestyle things. You know, you want to have heart disease? I can tell you what to eat and just sit there on the couch. You know, if you want to minimize your chance, you change your diet, you exercise, and so on. Whether intelligence is the same as that is really yet to be determined, because we don't know anything. We don't know anything that, in my view, increases intelligence. And we can talk about what that means, because it depends on the definition of intelligence.
I was going to start off with the question was intelligence, but we've gone down this path. Okay.
The good news about the genetics of intelligence, and I'm going to say something that is my idiosyncratic point of view. I don't know that what I'm about to say is widely accepted. But if there's a genetic component, and I'm talking now about individual intelligence, not these group averages, right. But if there's a genetic component to intelligence, individual intelligence, that means there's a neurobiology of intelligence, because genetics works. There's no gene for intelligence. There has to be genes for neurobiology and neural mechanisms, and an extraordinarily complicated cascade of neurochemical events that results in intelligent thinking. Okay, but it justifies a neuroscience of intelligence. And the field of intelligence research has been moving over the last 2 decades more and more toward neuroscience conceptualizations and methodologies to study intelligence. Now, one of the reasons this is important is that if you can understand intelligence on a neurobiological level, right down to the synapse, or right down to the dendrites of neurons, or the mitochondria in neurons, or any one of 1,000 different aspects of the molecular brain. If you can get some understanding of that, you might be able to tweak the relative systems to increase intelligence. So, let me give you a statistic that startles most people, and you will recognize immediately, based on the normal distribution of intelligence in the normal curve, that 16% of the population have IQs under 85. Now, you don't have to believe in IQ, or 85 is not a magic number, but that means that in the United States, about 51 million people have IQs under 85. And of those 51 million, there's about 13 million children.
Yes.
Okay? Now, yes. You want to talk about serious social problems? Yeah. You got 51 million people. Doesn't matter race, doesn't religion, doesn't voting preferences, doesn't matter. You got 51 million people who do not have the mental abilities to hold high-paying jobs and possibly even care for themselves. This is a very large number of people. Now, these people... That
seems like a pretty deterministic statement, though. That seems like a pretty deterministic statement that you just said.
No.
Do you mean probabilistically?
It's probabilistic. That, look, in the United States, there are about 43 million people living below the poverty line as determined by some government agency that does this. So think of a Venn diagram. You got 43 million people living in poverty. You got 51 million people with IQs that are low enough to make it everyday life difficult for them. there's got to be overlap between those those two sets of people. So if you could tweak IQ by just a little bit and move people from 85 to 90 or from 80 to 85, this is going to have a gigantic ripple effect on many, many social problems. Now, I explain all this for your listeners who would like to see my logic on this. It's in section 6.6 of my book, The Neuroscience of Intelligence. And this entire section is free on my website. So if they go to richardheyer.com and click on the Neuroscience of Intelligence, they'll go to a
I'll
page.
Put it in the show notes. Yeah.
Where they'll see a little tab where they can click on facts for and quotes for journalists. Go to that, scroll down to the bottom, and you'll see section 6.6 of the book in its entirety. And I explain this idea of why it would be a good thing to be able to understand the neurobiology of intelligence so that we might come up with ways to increase intelligence. Think about shifting the entire intelligence distribution a little bit to the right. I think that would have enormous implications for society. And you know, the more it's genetic, the irony is the more that intelligence is genetic, the more neurobiology might be involved and the more impact. I mean, think 50 years into the future when there's a molecular biology research program worldwide for understanding intelligence, just like there are molecular biology programs for understanding learning and memory, which, by the way, are elements of intelligence. So that if you want to solve Alzheimer's disease, you have to understand the neurobiology of learning and memory. And someday a pharmaceutical company is going to be able to tweak the brains of people with Alzheimer's disease to ameliorate that illness. And then you're on your way to coming up with ways to tweak similar symptoms in people without Alzheimer's disease, possibly to increase their cognitive abilities. That's the excitement of intelligence research in a nutshell. And it could be 50 years away, might never happen. Most of the people working in genetics, most of the people working in neuroscience believe what I just said will never happen because the brain is too complicated. The interactions of all these systems are too complicated to sort out, let alone how environmental factors like stress or other factors might influence the expression of genes throughout the lifetime. This is an extraordinarily complex set of problems to solve. But my view is we need to get started.
I would love to unpack so much of what you just said, but I was just curious, what was your link there to the race differences thing? Because I wanted to end that thread. You were starting to talk about it, and then you went off into the individual level.
You summarized the findings fine.
Oh, cool. Okay.
These average test score differences exist. They've been relatively stable over decades. What the explanation for them is not known, because everything that's been proposed as an explanation, from the number of words spoken in the household of infants to genetics, none of that has yet been demonstrated in a compelling way. Although, people say that with the new giant databases of DNA being collected literally all over the world, maybe the genetic story now will have the sufficient data in large enough numbers to test some of these ideas. Other geneticists say it doesn't matter how big the sample size is. It doesn't matter how sophisticated the genetic or DNA analysis is. There are just too many interactions to sort things out. And so you can never answer the question, does genetics have anything to do with any group differences on complex traits? Time will tell. That's my summary of where we are on that topic.
Okay, so lots to unpack. So I know you're interested in the development of intelligence, and that's a topic, a theme in your book. I'm wondering how you can possibly look at the development of intelligence by only staying at that biological level. You obviously need to look at how environmental factors interact with our biology. So are you saying that you don't think there's a lot of that we've really found out what those environmental factors are that are most important, and a lot of the ones that people have proposed turn out to not be as predictive? Is that along the lines of what you're arguing?
That would be a fair summary of where I think the field is. There are general environmental variables that undoubtedly must have an impact, like stress. Okay. Like poverty. Well, what aspects of poverty? How do you explain individuals who grow up in extreme poverty yet are intellectually extremely able? And how do you go about studying this in a systematic way? When sometimes there's a misunderstanding when I say things like intelligence is the single most important variable that predicts various measures of success. That is an empirical fact. So if you could measure, it doesn't mean that it's the only thing. It doesn't mean that it is philosophically the most important thing in success. It just means empirically, if you throw a whole bunch of variables into a quantified statistical procedure like a multivariate, regression equation to predict whatever measures of success you want to predict, the thing that always comes out first is some measure of general intelligence.
Now, does that matter what your dependent variable is? Surely what outcome you're looking at, IQ is going to have greater or less than predictive validity, like physics versus artistic achievement. We found in our data set shows widely different predictive validity of IQ.
That's correct. And when I said depending on what variable you want to predict, I'm talking about most of the variables that have actually been studied empirically to date that have some practical importance to most people, like academic success, like job success, those generic categories. But certainly, if you had a metric of kindness, if you had a metric of caring for other people, over and above the kind of the personality traits, who's to say that you wouldn't choose kindness over intelligence? Because I can tell you, having spent decades in university medical schools, I could easily rattle off a list of names of liars, cheaters, and thieves among the tenured faculty without hesitation. On the other hand, I could also rattle off a list of names of people who are extremely kind and generous, and they're on the same faculty. And they would agree with me completely on who belongs on the other list.
Yeah.
But that
For
list
sure.
exists. And they're intelligent, they're highly intelligent people, liars, cheaters, and thieves as well.
So it seems like, without asking you what do you think intelligence is, you seem to equate it with the kinds of cognitive processes that are measured on IQ tests, which are an assortment of cognitive processes that all seem to be positively correlated with each other, relating to working memory and reasoning, problem solving, on the spot, makes demands on executive functioning, these sorts of things. Is that how you think about intelligence?
Yes, I have a very narrow definition because it's based on what the research is about. Most of the research is about the general factor of intelligence, this general reasoning ability that you have across various kinds of different situations, called the G factor. Most of the research on intelligence is really about the G factor, and that's what seems to be most predictive and possibly most genetic. Now, what I just said is certainly open. I'm open to changing my mind on this as new data come out. The difficulty is the assessment of the G factor from various tests psychometrically is very sophisticated. People don't really know what psychometrics does, but it's a way of test construction that eliminates things like bias and maximizes the fact that it minimizes bias and maximizes the predictability of something with the test. So it's sophisticated. It's not perfect, but it's sophisticated. By contrast, the statistical reliability and validity and psychometrics of tests of things like wisdom or even creativity is not as high. Now, imagine, just as a thought experiment, you work in creativity. Your work is, I just read your imaging paper, fantastic. But imagine if you got a measure of creativity and you decide to give it to different groups, and different groups have different mean creativity scores. Okay, what are you going to do with that? Do you want to teach creativity in school, and you want to take kids in a group that have low creativity scores on average, and what can you do to increase their creativity? A lot of people have tried teaching creativity. It may even be helpful, but it doesn't really produce artistic geniuses.
You raise a really good point, and I think it might be a difference between us. I feel like I have two hats. There's one hat, I'm just the hat that I wear with you and I'm wearing with you right now on the science of intelligence, doing studies on it at a group level, not a group level, but a population level, an aggregate. But then there's the educational psychologist in me who's very, very wary about making statements about certain IQ bands and then prejudging individual person's future potential based on their IQ score. To me, that's a form of discrimination, actually, because you're taking population level statistics and you're trying to infer what one individual in that population is capable of doing in their lives. So I'm wary. I'm more worried about that than I am doing the good science and things of that nature. So that's where I'm coming from. Just wanted to share that with you.
There's no difference between those two hats.
Go on.
Because no one who's knowledgeable about the predictability of intelligence tests to job performance or to life success believes that where any individual is on that IQ, in those IQ bands, determines their life success. These predictions are generic. They're not perfect. Maybe they predict anywhere from a third, maybe as much as 60% of the variance, sometimes maybe a little bit more. But you could ask the question slightly differently than the way you proposed it. You can ask, is there any value in knowing your IQ score? And most people who study IQ, and I include myself in this, would say, not really. I get emails all the time from people who have read my book.
They want you to test them?
Who follow me on Twitter. And it's more like they've been tested and they know their IQ. And they say, look, my IQ is 110, but I want to go to graduate school. Do you think I could be a successful graduate student? And my answer always is, your IQ score has nothing to do with what you just asked me. I would have no way of knowing this. The only way you can find out is go to graduate school, try your best, and see.
What do you make of cases where there's a mismatch? This is an interesting question because I've been thinking a lot about this. What happens if your achievement trumps your so-called potential? I had a learning disability when I was a kid, and I don't want to harp on this story, but just briefly, because of auditory issues and various other issues, I didn't do too well and didn't do hot on IQ tests when I was 7 years old or so. And if someone tried to predict, my future based on that snapshot of my life, they would be shocked to see that I got a PhD from Yale. And so I did it. I tried it and I did it. I was successful in it. So just like your advice, go for it. What happens when your actual competence surpasses the test? Do you throw away the test? Like, do you believe the tests are the truth, or is the truth? Like the truth of your competence?
I think you
in the
answered
world.
your own question. Obviously, the truth is the truth, but I will tell you my own story about this.
I'd love to hear it.
When I went to graduate school at Johns Hopkins, I'm going to speak a little slowly here because I want to be careful the way I say this. There was a professor on the faculty in the psychology department who was a preeminent psychometrician. And he literally believed everything you needed to know about a person you could tell from their test scores. So that whenever there was a conversation and a name would come up of a previous graduate student, for example, this member of the faculty said, "Oh, yes, so-and-so, I remember him. His GRE score was this. His Miller analogy test score was this." And he would then say something like, "Yes, and he did as well as you would expect from those scores," words to that effect. And this faculty member was well known, a highly regarded individual, a very sweet person, by the way, a gracious, terrific mentor person, human being. But this is the way he viewed the relationship between test scores and people. Well, I corresponded with him shortly before he passed away. He was very elderly. It was many years after he left the university. I had not corresponded with him for many, many years. And then for various reasons, I did have a chance to correspond with him. And I was later told by somebody else who also was much closer to him than I was, that he remarked to this other person about me, "Rich, he seems to have achieved a lot more than I would have thought from his scores."
How'd they know your scores?
Well, he knew. Everybody on the faculty could see your application. It was all on the scores.
I see.
All the scores were on your application at that time. And he looked at them, and he remembered them, and he believed them. And now I took this as one of the great compliments of my life, by the way.
Okay.
So, yeah, I think the bottom line is you can't over-rely on a test score as just a test score. Life is complex. Reducing people down to a few scores. Physicians kind of do it all the time. You go to a physician and you say, "Well, do you remember me?" "Oh, yes, you're the person with blood pressure over, this and that, and your weight. I told you last time you had a weight." They remember you in terms of numbers. So it's not that outrageous a thing, except it's kind of an outrageous thing.
Yeah.
So I don't think I disagree on this at all.
Well, I wanted to clarify. You said you didn't think that hat 1 and that hat 2 were different from each other. And then it seems like you're now agreeing they are different from each other. So I'm trying to clarify what you're saying there.
Well, the scientist hat tells you what the prediction is.
At the population level.
And your education psychology experience tells you that there are a lot of exceptions to the prediction. But the people who make the prediction wouldn't dispute that there are many exceptions. But the reason you can have some kind of science is because you have some level of predictability. It's not deterministic, though, and there are many exceptions. So I know many, many cases of kids that had dyslexia who grew up to be multimillionaires through their own business sense.
Oh, yeah.
There are many, many things. I think the mistake is going the other way. The mistake, I think, is that because of all the exceptions you and everybody else personally know, they say, well, the science can't be true.
Oh, I see what you're saying. Well, yeah, that's maddening to scientists. But you see that with everything, though, that way of thinking, right? When we talk about sex differences and personality, for instance, we could go down the line of the most controversial topics. Here's the thing, how do we do good public science communication where we explain that, the exceptions matter, but so do the generalizations. I wrote a tweet about that actually just a couple of days ago. I said both matter, both can be true at the same time.
Yes,
but it's
like.
Did you like that tweet?
Yeah, I gave it a like.
Thanks.
How
do we responsibly communicate that to a public that seems to want to take one side or the other?
I can tell you I've been trying to do this for decades in my public speaking. And the first step is you have to do public speaking. You have to engage the public. Yeah. Not everyone can do it. It took me a while to kind of hone my public speaking ability. The lectures I did for the Great Courses Company, which have been popular, that helped quite a bit. But I'm only one person. Scientific communication is not easy because scientists tend to qualify things, and they tend to, before they get to the point, they tell you what the problem is and the method and the details of the method, then how it was analyzed, and finally they get to the result. And this is not the way you talk to the public. I start some of my public lectures with a picture of a well-known person, an autistic savant, high-functioning autistic savant. And one of the things he's done is memorized the string of digits for pi. And I start by asking the audience, pi is 3.14, and then there's an infinite series of numbers. And I tell the audience, how many do you think he memorized? He took a month, studied a computer printout, memorized a string, and then went on the BBC and publicly started regurgitating the sequence of pi as people checked along the way. How many digits of pi do you think he did? 500, 15,000, The answer is 22,514.
Is that Daniel Tammet?
Yeah. Yeah. Mm. And he wrote an autobiography.
I know him.
He's a very interesting person, isn't he?
Yeah. Yeah, very interesting.
But the point is, there is a brain that can do something most people cannot do. Is he a genius? And then we have a conversation about what these words mean. And then we talk about synesthesia, a condition an unusual brain condition that apparently he has. So there are ways to engage the public without explaining what a multiple regression equation is, starting there, So, but it's highly important because there is a hunger to know these things. Yeah. And in some ways, the public is way ahead on their understanding and interest in intelligence than some academic departments, where intelligence is a fighting word.
Yeah, I hear you. The excitement that I had for the field early in my career was purely about the least controversial aspects of the field, really. It was like, I was just so curious, like, what are the environmental correlates? What are the neural correlates? If we decompose an IQ test to its various components, what are the different strategies people use? I mean, really nerdy things that I never even imagined in a million years could be controversial. You know what I mean? It was just like me just being really nerdy. Now, I and I'm going to keep saying this over and over again. I wish that the field would stop being hijacked by, well, A, it's past. IQ tests were used by by unsavory purposes in the turn of the 20th century. I mean, we sent back a lot of immigrants. We using the tests. We used it in the army for various ways that probably weren't right. It has had a history of abuse, but that doesn't necessarily mean the test. The test itself is a blunt instrument. It's not, the test itself is not evil. It can't speak.
Yeah, let me say two things about that. The first is the abuse empirically seems to be less than most people, including people like me in the field, have always believed. Russell Warren? Russell has written a book, 35 Myths About Intelligence, or words to that effect. It's just about to come out. He's talked about it on his Twitter feed. And he goes into some of the detail of this. And at one point, he actually went back to immigration records and found the number of people who were sent back as mental defectives based on tests, and was some tiny proportion of 1%. I mean, it happened, but it's not this gigantic malpractice. So that's the one thing. So it's not to excuse it, but I think it's been exaggerated without really an empirical investigation of the facts of it. And the second thing is there was an editorial in Nature, I think in 2015, on the occasion of the publication of the largest genetic study of educational attainment, which is a proxy for IQ. It was Snyder's. So they published this in Nature, and they found basically you could have polygenic scores that would predict education attainment, and it was a giant sample. I think memory serves, it's around 300 people in the sample. Now we have a sample of 1.2 million doing the same thing. But that was a big deal in 2015.
But those effect sizes are way too small.
The point is, Nature published an editorial on the occasion of publishing this, what at the time was a landmark study. Okay. The essence of the editorial was intelligence is a legitimate thing to study. It may have a bad history, but we have to move on. And they cited a special issue of the journal Intelligence, at the time edited by Doug Detterman, on teaching intelligence in universities. And I had a little piece in there, and other people had pieces in there. And the surprising thing was there are very few courses on intelligence in undergraduate education at colleges and universities. Very few. Most people don't want to teach it because you have to talk about some uncomfortable aspects of it in the context of the much bigger context of all these other interesting and important things. But Nature, I regarded that editorial in Nature as an absolute turning point. Because they basically said it's okay to study the genetics of intelligence and intelligence itself. And this is the future, is what they were, the way I remember that editorial. So it does pain me also to see all of this fascinating and exciting and potentially extremely important research being hijacked by these old controversies, especially since racists don't give a damn. They're racist.
It doesn't matter what our data shows, they're going to find a way of...
Everybody's going to change their mind if you show that your racist ideology is based on empirically false things. So the fact that is even affecting the funding for intelligence research. I thought there should be a National Institute of Stupidity, just like there's a National Institute for other diseases. And of course, the National Institute of Stupidity would have to fund research trying to cure stupidity.
Oh, I see.
And that the only way to do that is to understand intelligence.
Hi, everyone. I'm excited to announce a new 8-week online course that will help you live a more fulfilling, meaningful, creative, and self-actualized life. For the first time ever, I'm taking my Columbia University course online. This 8-week online course, which will run from September 5th to October 24th, is grounded in the core principles of humanistic and positive psychology, and will help you in your own personal journey to realize your greatest strengths and become more fully human, accepting and becoming flexible with the totality of who you are, so that you can become the person you most want to become. Save your spot today by going to transcendcourse.com. That's transcendcourse.com. Save your spot and learn how to become the best version of yourself by going to transcendcourse.com today. Now back to the show. So intelligence, we're both agreement. Intelligence is important, but it's not all there is to a human. There are things, there are caveats. I think we have a responsibility to just say these caveats because people just misinterpret it when you say intelligence is important, that somehow you mean it's all that's important, right? or that you equate it with human worth. I don't know about you, but I don't equate an person's IQ score with their value as a human being.
No, just the opposite. I mean, what I argue in my section 6.6 is that you can't hold it against someone if through no fault of their own, they don't have the mental skills to be really successful in society. And therefore, the role of government is to give them a safety net, to provide for them. Now, how you do that, you can discuss that, you can debate that. I was leaning toward universal basic income for low IQ people, but then obviously, if they have trouble managing money, that may cause more problems. So you need some discussion about how policies can help people. But people have to be treated as individuals. And clearly, just my example of the people I know in medical school who are liars, cheaters, and thieves, I mean, you cannot equate intelligence with human worth. I also say, however, and this might seem contradictory, but I also believe that all things being equal, more intelligence is better than less. And therefore, we have a moral obligation to try to increase intelligence if we can. If environmental manipulations work, we should support it. So having smaller class sizes increased intelligence, I'd be all for it. Now, smaller class size has no relationship to the development of intelligence.
I think that's really an interesting argument because I think there's trade-offs with all the different traits we have in the world. And it's fascinating when you look at the brain of the neural networks associated with imagination, sometimes are exact opposite of the neural networks activated on IQ tests. Sometimes in order to be creative, you have to tone down that executive network. I think it depends a lot on what you're trying to do, what you want to do in your life and what you want. I personally think I'd rather have a couple extra imagination points, even if that means sacrificing 5 IQ points. So what do you think about what I just said?
Nothing you just said contradicts what I said. They match. So I didn't say that IQ was the only important thing. What I said,
all else being equal.
I do think it's an empirical fact that more intelligence is better than less. That's all I said. More creativity is better than less. More kindness is better than less. More tolerance is better than less. I don't know how to get people to be more tolerant. I don't know how to get people to be kind. I don't know how to get people to be more intelligent, but I'd like to find out. I'd like to live to see it. So yes, I think you can make a value judgment. Imagine a thought experiment where we have the ability to manipulate the intelligence of a child or an infant, and you give parents a choice. We can turn the thermostat up, or we can turn it down. Who would select to have a less bright child? I can't even imagine that would be. Now, if you said you can have a choice between more intelligence or more charisma or more physical attractiveness. Now, this might present people with a dilemma.
Now, if you start adding in other variables,
but intelligence, there are plenty of people who are highly successful based entirely on their looks. I'm not one of them.
I was going to say, like, people like you are a good example of that.
It's a burden. What can I say?
Yeah.
So when you talk about something like more intelligence is better than less, that doesn't mean that it makes you a better person. It just gives you more, reasoning ability, which you can use for good or for ill. And if I could make people kinder, I would work on that. But my field is intelligence.
Yeah, no, I hear what you're saying. I have a allergic reaction to reductionism, so I'm thinking about how is reducing intelligence to brain waves or neuroscience. I know that you use words such as astonishing in your book. You say astonishing neuroscience methods. I know you're very excited about it, and I don't want to take away that excitement because it kind of excites me when I see someone excited about new frontiers. I just am asking a question in the sense that how do you not view that as reductionistic for understanding intelligence?
Many aspects of science require a certain amount of reductionism. So reductionism, studying something without reductionism, I think it was E.O. Wilson. I'm going to screw up this quote, but E.O. Wilson said something to the effect that without reductionism, you have art. With reductionism, you have science.
It's an interesting quote. I guess I suppose it depends what your purpose, For scientific studies, reductionism sometimes is incredibly important to isolate a variable and to narrow your construct. But dealing with the messy reality of school children, for instance, and trying to give them resources and see who would benefit from what resources, what are kids' dreams, desires, what are their future goals. It seems like asking people what their future goals would be more beneficial for understanding the human being than just looking at their brain patterns. Do you disagree with that?
No. If you are a vocational counselor, you need to see the person in as big a context as you can imagine.
Yeah.
If you are a therapist, you need to see the person in the biggest context you can imagine.
Exactly.
If you are a university admissions officer, okay,
dun, dun, dun.
This gets a little interesting because you can see a person in a context that has two elements: a subjective element of letters of recommendation, achievement in high school, how many nonprofits high school students started, how many famous friends their parents have that can write letters of recommendation. And you can have an objective component like a standardized test. And as you know, all the research shows that all that subjective stuff adds little, if any, predictive value to the objective test. Now, it goes against people's sensibility. When I was on the medical school admissions committee many years ago, my colleagues would sit and they would spend half an hour or more on a folder reading the personal statement, saying things like, what do you think? You got this grade in this course and this. And I would finish 4 folders in the time they were taking to do one because I weighted the MCAT score. And then I looked for reasons in the folder. If a person had a solid MCAT score that was the criteria that met the criterion of our university, then I would just scan the folder to see if there were any red flags about why this person should not get an interview. And I knew I could not read the tea leaves. I could not extract nuances from the rest of the folder, except if there was something like, well, let me explain to you why I was arrested after that barroom fight. It was an actual case, by the way.
Oh, really?
Yeah. Flags like that got my attention. But by and large, the research shows the objective measures are as predictive as they can be without adding the other stuff in. So the goal of admissions officers is to make the fewest errors possible. Now, they have many criteria. They have diversity as a criterion. That's you can't really tell that by a test score. But test scores typically nowadays are only one of many, many factors that are used.
Sometimes there's some test optional now.
Yes.
Universities.
Now, the University of California is stopping the standardized tests for 5 years. They're going to develop their own. This will be very amusing to see what they come up with that's different and more predictive. They probably won't even use the word predictive. They'll just kind of call it useful.
Useful. I hear you, and I wish that we had better objective measures of more of the totality of a human. I resonate with your point that we have to be wary about relying on subjective measures just because our heart is telling us to do so. But I also think that it's important to have a heart. and I know you don't disagree with that, but I'm saying, this is just a point I wanted to make. I wish that we had more reliable and valid measures of a child's soul, of a student's determination, I should say, the fire in their eyes. You can't see an applicant's fire in their eyes by test scores on a piece of paper. So these are maybe intangibles, but I wish that we did a better job scientifically measuring some of these seemingly intangibles.
Well, that's what interviews sometimes try to get at. And interviews are notoriously unreliable, very subjective, and they're very subject to manipulation.
Charm, right? You were talking about charm earlier. Yeah.
The first thing that when I counsel people on how to approach medical school interviews, first thing I tell them is, your job is to make the interviewer like you. And the rest is downhill. Yeah. And you have about 45 seconds from the time you start the interview to make that happen. Because he or she is going to make that judgment in about 45 seconds because they see a million people. You have to stand out. And if you're likable, the rest of the interview will go well. And I think that's true in a lot of circumstances. Likability is important.
It's important. A lot of characteristics of a human are important, but germane to our topic today, so is intelligence. So I'm going to end on that note, and I want to thank you. I really respect the work you've done in your career, and it influenced me in my own dissertation when I was working on my own dissertation on broadening general intelligence to unconscious implicit learning measures and creativity. I found the PFIT model you and Rex Young developed very, very important for my work. So look, I want to thank you so much for being such a legend in the field of intelligence. And
on one hand, that really is a warm, fuzzy feeling that I'm getting, and I appreciate it. On the other hand, it's making me feel even older than I am. Well, when I give talks now, there are people in the audience who do very sophisticated brain imaging who literally were not born when I did my 1988 study. So time marches on. And by the way, I will end on this note. This is why I am optimistic that very complex problems like figuring out the neurobiology of intelligence, it's a matter of time. And if you go back 50 years ago to where we are now and what we know about the brain and our methodologies, light years. And so imagining 50 years in the future, I think, it's a lot is possible that seems impossible now.
Well, thanks for coming on and talking to us about the future of human intelligence.
Well, I appreciate the chance and my best wishes.
Same to you. Thanks for listening to this episode of the Psychology Podcast. If you'd like to react in some way to something you heard, I encourage you to join in the discussion below. Also, please add a rating and review of the podcast on iTunes, and subscribe to the Psychology Podcast YouTube channel, as we're really trying to increase our viewership on YouTube. Thanks for being such a great supporter of this podcast, and be sure to tune in next time for more on the mind, brain, behavior, and creativity.